Hello, this is Nate Latavik,
This is Brandon Gary.
And I'm Ty Veo.
and this is our senior project, the redesign of Mustang 60 machine shop and arrow hanger check-in, check-out system. Before we get started, we'd like to give you a brief overview of what we'll be covering in this presentation. We will first start with an introduction to the two shops on campus. We will then present our problem statement, then dive deeper into the background of the project. From there, we'll list our objectives, provide information on our literature review, talk a little bit about design, and finally describe what's next for us in this project. Okay, Mustang 60 and the Arrow Hanger are the two main machine shops on campus for Cal Poly students for students to utilize a wide assortment of shop machines, tools, and their various academic, club, or entrepreneurial endeavors. Both of the shops offer trainings and certifications to use certain machinery and keep track of student work hours. While these shops operate in separate campus locations, they share similar operating procedures, as well as the same operational database management system on the same server. This database management system, designed using Microsoft Access, is used to perform a host of recording tasks, most notably to record students checking in and checking out of shop locations. Moving on, here is the problem. Due to the current state of the operational database management system and its accompanying physical check-in, check-out system, the shop loses student work time and employee productivity due to a host of inefficiencies. The database has many bugs that can corrupt student data. The data that is collected is not easily accessible nor readable. Data is collected, but there is no meaningful applications or forms that are displayed to give information, such as hours put in by a club as a whole, a ranking of hours by major, or other possible lists. The desired state that we wish to achieve is a system that is user-friendly, time-efficient, and free of corrupting bugs.
Now we're going to talk a little bit about the background. In the past, there have been several attempts to implement a better check-in, check-out system with these four machine shops on campus. Some of these past attempts have been aimed more at creating a unified data sharing program between the four machine shops at Cal Poly. The biggest issue with all of the machine shops at Cal Poly is that they all have a different check-in, check-out system and certification standards. The last issue is that the current system in place yields very limited data that the shops can show to their current sponsors and even potential sponsors. Now we're going to talk about our objectives. We want to provide a comprehensive background and subsequent literature review to aid the reader in their understanding of database management systems and how they work in tandem with facilities design. Overall, we're going to try to develop an understanding of the current state of Machine Shop 60 and the Arrow Hangers database management system and the accompanying physical operational procedure. In this process, we will need to identify the inefficiencies of the current state of the machine shops and their database management systems. The last piece that's going to go into our project is going to be providing a redesign of the current database system and the accompanying operational procedures that address the identified inefficiencies. Now we're going to move into our literature review. So we've done a little bit of research and read a few articles, and most of our articles consist of materials pertaining to different types of databases and what each one is used for, the different types of data that can be collected from the project and how to use it, how to design and implement a successful database system, and how a successful database fits into the physical space of the system.
There are going to be numerous tools that we will use for this project that we have learned in our industrial engineering curriculum. The main tools that we will use for this project will branch off concepts learned in database management and system design, or IME 312. For example, we will have to understand the concepts learned about ER diagrams and make sure the correct data points will be placed in the correct fields. Project organization and management will be useful when managing the timeline of this project, as well as when giving updates to our stakeholders on the progress of the project. Tools learned from facilities planning and design can be handy when designing the physical check-in, check-out system, along with topics covered in industrial costs and controls, as well as engineering economics. Tools learned in test design and analysis will come in handy when determining the design and implementation of the data collection portion of the project. Finally, we will draw tools learned from human factors engineering to make sure our interface is user-friendly and easy to use. At this time, Microsoft Access has been determined as the ideal software to create the check-in, check-out system on. Microsoft Access's ability to provide an easy-to-navigate yet powerful user interface, along with its capacity for large sets of data, makes it the ideal candidate for our project. Additionally, a Microsoft Access database is currently used by Mustang 60 and the Arrow Hangar, so it will require less complications when implementing the database update. Microsoft Access also has the capability of allowing data visualization within the application, so user-friendly forms can be created to display the collected data. The option to export the forms to other formats such as Excel, PDF, and CSV files is also a big bonus. Another aspect of our project is the design of the physical check-in, check-out system. A redesign of the physical queuing location located in both Mustang 60 and the Arrow Hangar will be initiated with the update of the system. New card ID scanners will streamline the check-in, check-out process by removing the requirement of having a shop tech or student shop tech present when users need to check in and check out. Space-efficient relationships between the queuing area and the check-in station will need to be developed and then tested by the machine shop users and its employees. From these tests, data will be collected and the functionality of the system will be able to be analyzed.
All right, so what's next? Well, we have the following. We'll be finishing the design of our two adjoined systems. We are currently in the drafting stages. From there, we will be conducting tests, first virtually in the lab on the database, and then conducting a pilot in the shops. From there, we will be using our time study and observational skills to determine the effectiveness of the new system versus the old. Once data collection is complete, we will conduct a comparative analysis of the two systems to determine if there is a difference in speed. We will be interviewing shop users, as well as to get feedback, and adjust our designs as time permits. Thank you for listening to our presentation.